Thanks. So I'd like to welcome everyone today and thank you for your time. So my name is Carl Sara, and I'm the head of tech innovation for Sucrafina, and I manage our ag tech investments. That's both supporting the individual companies and then helping them deploy within Sucrafina. I've got with us here today Leon Sanchez, who's our head of global agronomy, and Robin Hoof van Huidfonson, who's here as our sustainability head of sustainability project. If we could just move to the next slide, please. Great. So in Stucafina, we're a global company. Our company is based in Switzerland, but we have local teams. And this is very important for us that we're not just focused on being a multinational, that we try and develop all of our projects locally and execute them locally with the global support. As a company, we are very focused on innovation. We are a green coffee company, so we are involved in the green coffee trade. I'll explain a little more on that. But as a part of that, innovation is a core value for Sucrafina. And we really try and drive shared value and add value into the supply chain. So we're not simply just drawing on the supply chain, that at the points that we engage with it, that we're able to help to add value for all of the members within that supply chain. Next slide. To give an idea about Sucrafina, I mean, the numbers are here, but the key parts is that we're engaging with more than 200,000 grower partners. So that's farmers or people directly involved in the growing of coffee. And with more than 60 washing stations. So that's where cherry comes in and coffee is processed. We are the largest owner or operator of wet mills for coffee globally. And that means that we have a lot of contact points with producers in countries all around the world. The project that we're talking about today, though, if we could go to the next slide, is based or found home in Vietnam, which is the second largest producer of coffee globally, and a very important place for Sucrafina. So to explain what we're looking to achieve is that we already have methodologies for delivering fertilizer, but the latest part that we've been working on is delivering fertigation as a methodology for delivering fertilizer, as well as the opportunity to engage irrigation at the same time. And while being cost effective in terms of versus hand deployment of and mechanical deployment of fertilizer under current methodologies, it is less capital intensive, it's more accurate deploying the point, but we could be more cost effective with it. It's quite capital intensive to deploy fertigation amongst a lot of smallholder producers. And we really want to be able to make sure that we can achieve scalability initially across the Vietnamese smallholder coffee farmers. But I think important to note that if we find a really effective methodology here, then we have the ability to support some legitimate global scale for the program. If we could move to the next slide, please. So to get a bit of a background, when we're referencing a smallholder farmer, we're talking about someone who has 1 to 3 hectares. And the challenge is that they're often over applying fertilizer. Now, it could be as simple as somebody getting a recipe, which is a theoretical yield per hectare, but when it's being deployed, they're literally putting their hand into fertilizer and spreading it on the ground. And so with methodologies like this, we can really see ineffective or over application of fertilizer by 30 to 50%. It's difficult to scale fertigation projects because of the high capital cost. So while they're more effective and efficient in deployment of the fertilizer over the period, and it gives us a lot more control as to exactly how and when the fertilizer is applied, the capital cost can be restrictive for smallholder producers. Now, while they're often grouped in villages or close together, the farms or producer units aren't always directly side by side. It's also important to remember that a lot of these, because they are smaller units, it is the farmer themselves deploying that fertilizer, or in a slightly larger scale, they need to be able to recruit workers from around them. And because of the seasonality of this, the labor isn't always available. and or it can be expensive to find the right labor to be able to do a job. And when we say highly vulnerable to weather, we mean when we're deploying um, uh, fertilizer like hard capsules. If it rains too much, it washes it away. If it doesn't rain enough, we don't get enough saturation and penetration and effectiveness from the fertilizer. So the opportunity is really for some demonstrations using subsurface drip fertigation, and they've given us really positive results with about a 50% reduction in the use of fertilizer. And in the end, for the producers, this is yielding a 10 to 20% yield investment. This is great in an environment. I'm sure you've all heard coffee prices are really high at the moment. And that's really providing a significant increase in income for those producers. But we also must remember when the price is lower, that while the dollar return might be lower, it can also restrict a producer's ability to make capital investments that they might be willing to at the moment. And so if we could move to the next slide. So when we look at what the technical requirements are, that we need to operate with a minimal external support. So this is understanding that we are in relatively remote areas, and that we need a system or a delivery methodology that can be quite robust. Now, the delivery methodology needs to be lightweight, simple to install and maintain if it is indeed a CapEx investment, and that it must function in really difficult terrain. By nature, coffee grows on the side of hills. It's not sort of generally on a nice flat piece of land. It's not always in perfect rows. It's not always perfectly pruned. And importantly, there are often trees, they may be for shade or just general environment trees, which are inside of the plot. So important component about that means that the natural thought could be, let's just go to a drone, but just a simple drone application has its own challenges, not only obstructions from trees, which from generally could be worked around, but then we also have the requirement that we're not looking to deliver fertilizer onto the leaves of the trees. We're looking to deliver fertilizer directly to the soil and into the root zone. And that if we deliver the fertilizer incorrectly, fertilizer which is intended for the ground can burn or damage the leaves if it spends time on or dries on the tree. And so it must integrate the agronomy and soil testing into this program as well. There's no point simply just pushing out random amounts of fertilizer. So making sure that we have a methodology to accurately assess and support the producers to make sure that they're dosing the right value. KPIs that we're really looking for here is that we're looking to reduce 50% of the fertilizer use for the producer, and we're looking to deliver an improved yield of at least 10 to 20%. And we're also looking to have minimal water use and runoff for general environmental issues. Next slide. So the pilot and timeline, a crop cycle is 1 year. Coffee generally has one crop within Vietnam when we're looking to run this project. And so being able to see this duration within 6 to 12 months, because that's a crop cycle, which is an ability to deploy and ability to see the value which is added by the fertilizer delivery method. What we need to validate is being precise around what's being delivered, making sure that we're efficient in its delivery, and the yield outcomes are we have historical data, but we also need to make sure that we're recording the data moving forward to look at those yield outcomes. And the total cost versus fertigation is important. Important to note that we do have fertigation in play. We're looking to find something that can help us scale this more and make it more achievable and available for producers to be able to gain the benefits from it. So we'll be working by a pilot plot, which we're able to help provide as Sukafina, and that'll be directed by the Sukafinas, or directed and supported by the Sukafina's agronomy team locally inside of Vietnam, as well as resources surrounding that. The solution provider should be able to provide all of the training materials and field manuals. It's important that we understand that the people executing this, being producers, are less likely to be scientists within themselves. And then we're looking as a financial consideration to find a way which has a 50% cost reduction over 3 years versus fertigation. If it is a capex deployment, then an idea would be like a 10-year life cycle, which is what we're looking at on a fertigation deployment. And that would include 2 years of agronomy support. It's really important to say that this does not have to be a like-for-like fertigation deployment. It has to achieve the same things as fertigation. So the answer, the solution here doesn't have to be, please chop the price of fertigation in half. Great if we can, but we're really looking for innovations in the way that this can be delivered. And the capex should be at least as efficient as delivering the systems and providing the nutrition. Next slide. So we've got a bit of information here about where the work is being executed, which is up in Lam Dong. I think really important to note that while there are larger farms, the focus is around supporting family farming, and that it must be business orientated. So this isn't just some lifestyle farms. I think most of the other pieces here are sort of pretty clear, but generally not all of the farms have irrigation in place already. And so, in fact, most farms do not have irrigation in place already. So the fertigation project was a part of being able to facilitate that. We are seeing more irrigation move through, but of course there becomes the direct cost for that. Very important to note that whatever solution we do find, that it is able to be applied across a lot of different terrains. So when we're talking about steep, it can be not only steep and difficult to walk up, like it's not something where you can just wheel something necessarily easily, but also we have to remember that the trees themselves have a relatively high density within those plots. So there's not a perfect 2-meter strip in between each tree or each row, which you can drive something up and down that is high. However, it is possible, and we're able to look at those components and explain in more detail. And so it's fully or almost full sun coffee with around 1,100 coffee trees per hectare. So the approximate is 3 by 3 meter spacing, but that's between the tree root and stumps themselves, trunk, rather than that an inference that there's actually a 3 meter by 3 meter space with no branches or anything around them. There's a high use of synthetic fertilizers, and mechanization is very low. So harvest is by hand, and most of the work that happens out in the field is by hand or by very low mechanization assisted, like weed whackers and methodologies like that. Next slide, please. So the potential impact here is really significant, both in this project, but in the opportunity with its global scale. Reduce fertilizer waste, possible fertilizer runoff, all of those components are very environmentally protective. We know the damage or harm that overuse of nitrogen can create. But importantly, we're also looking to support the producers to be able to become more sustainable themselves and create better business models to support them. So lower cost inputs gives them an opportunity for a higher profitability as producers. And the expansion and access to precision agriculture tools for smallholders is not just a Vietnam challenge. I'm in Uganda at the moment. We've got significant operations here as well as globally across all of our, if you can think of somewhere you're producing coffee, then Sukafina has operations there. And this can create us an opportunity to be able to support these programs for a successful solution, be able to expand it out globally. And critically, the fertigation can also help provide resilience against some drought, not only in terms of delivery of water itself, but if we are experiencing drought, it can make it difficult to deploy fertilizer effectively because the water is needed to be able to push the fertilizer into the ground. And last slide very quickly. Really talking about the incentives, I think that there is a broad range of incentives and it depends on the approach that the solution might come from. But we have access to a lot of producers, and through those producers become a lot of very interesting data. Um, Going alongside of that, Sukafina, Leon and Robin and the team have done a lot of work to be able to pull together a lot of sustainability information, but also a lot of historical data, which is able to help support and answer questions off the bat. As a company, we invest in businesses which are able to help support the primary focus of Sukafina, which is to be able to trade green coffee. And so if we're adding value in the right place at the right time, we can really add a lot of support to the solution to make sure that we can really deliver. And likewise, we see the solution here as something which could apply to not only coffee, but the right solution could also likely apply or be easily adapted across a broad range of other products which are grown in the same instances or places as well. So that's all from me in terms of a presentation. But I see we've got a couple of questions on the side. We jump straight into those.
Yes. So thanks for your presentation, Carl. Let's just quickly address the two questions we have. So Ilya asks a few questions. So crucially, do coffee farms generally have reliable mobile network coverage? Do they typically use drip irrigation? And do they require EC or pH control systems?
I would say, as a generalization, every farmer knows when coffee goes up before we do. So their access to mobile data is generally very good.
Okay.
But it's not necessarily 100% of a farm might not have perfect coverage. So I would say generally there is good mobile access, but it is not always a guaranteed, and it is not always a guaranteed over 100% of the farm. The second part, do they generally use drip irrigation? Where irrigation has been applied in Vietnam, which is a small percentage of the total crop, generally drip irrigation is more effective. And for the fertigation program and the deployments that we've done, it's been done using a drip methodology. Using sprinklers is very inefficient, but it also comes back to the challenge of using sprinklers then would put fertilizer onto the trees, which can damage the trees as well.
All right.
And
EC and pH control.
yes, that's a standard part of soil monitoring,
Okay.
and it's important.
All right.
And
Next question is from Anya. Where does
generally imported. And what are
generally
the water
imported?
sources? Water sources are generally local springs, but it can vary from case to case. Some of them will draw from small rivers or water sources, but
Okay.
generally springs, and they're often under fertigation. They're tanked first, so we'll often consolidate in the tank before it goes through fertigation.
All right. So for those listening to the recording later, that was a reference to the source of the fertilizer and then the source of the waters for irrigation. And finally, Nisha asks, what is your current application method omits foliar application completely, and so do you require only a soil application of fertilizer? And then the second question from her is, please share what your nitrogen source is.
Okay, we have Leon on the call. I might invite him to get a little specific about the fertilizer, but I
Sure.
would say we currently aren't using foliar application because of the potential damage it can do. But if there could be a solution, then we could be open. But Leon, really welcome your input with this.
Yeah, when we talk about, can you hear me, Carl?
Yes, perfect.
Yes. Okay. When we talk about foliar applications, yes, I mean, we could be interested in foliar applications, but the challenge is basically about the main application of fertilizers for the crop needs. So I'm talking about the soil applications that the farmers are doing actually to replace the current method with, let's say, a new technology. Plus, of course, we can apply foliar applications, but the foliar applications cannot provide all the crop needs. So this could be, let's say, for certain micronutrients, etc., etc. And regarding the nitrogen source, most of the farmers move to NPK compounds from, let's say, the last 5 to 10 years, where they were very much focused on ammonium, ammonium nitrate and urea. But actually, as I said, basically it's NPK, and the NPK compounds, they got a blend of, let's say, ammonium and nitrate in the end composition.
All right.